I'm Alison Watts, and I want to talk to you a little bit about some really cool work we have been doing using eDNA to characterize marine systems. So you've probably heard about eDNA. It's kind of a shorthand form of the word environmental DNA. And environmental DNA is just DNA that's present in the environment, whether it's water, whether it's sediment. All organisms pretty much shed DNA through their scales, their skin. If they go to the bathroom, if they reproduce, they're releasing DNA into the environment. And we can collect samples of the water or the sediment, we extract the DNA, and we use that to see what organisms are present. We've been using this really successfully for a bunch of different applications. We've been doing a bunch of work detecting fish in estuarine systems, and we find that using the water samples, we are able to detect pretty much all the fish that we expect to see present in that system. We can also look for different types of organisms. So for instance, this is some samples that we took from deep sites in the Atlantic Ocean. And for each liter of water that we pulled up, we detected generally a couple of hundred different species. And most of those are microorganisms. So there might be fungi or diatoms or bacteria, but we also see fragments from larger organisms like fish or whales. We didn't actually see whales in any of these samples, but people do, and that is a way of detecting larger mammals. We can also use that whole community to look at change. So these are samples again from Great Bay, where we sampled in June, August, and October. And over time, we see that the biological community shifts, which you would expect over the course of the summer. But this is a way in which we can actually quantify how that changes and which species become dominant at which times of year. We can also use this method to see how ecosystems shift in response to either restoration or to a stressor. So for instance, if you are interested in wind farms and how those wind farms might affect the biology of a location, we can use eDNA to characterize the biology that's present before the installation occurs, during the installation, and then continuously monitoring over time as the installation matures. And this is being done in several different locations, and we're finding that it works extremely well as a complement to other types of monitoring methods. So you've probably heard of eDNA. You're also probably familiar with a lot of different monitoring methods. And what I'd really like you to get out of this is you should really be considering eDNA either as a standalone or as an add-on to existing monitoring methods. It will make a difference to the types of biology you are able to detect, really. And I'm happy to talk to you about it if you want to hear more about it. Thank you very much for stopping by.